Properties of quadratic functions in standard form, section 5.2. If you would have had me in Algebra 1, you would have done some of this already. This should actually really hopefully review after a couple problems. You're like, oh yeah, I remember that. Would have been the last thing we did. But properties of quadratic functions in standard form, two things should stand out to you right away. First of all, what does it mean to be a quadratic? Well, when you hear the term quadratic, what do you think, Nick? X squared. Okay? We're dealing with x squared this chapter, basically. Okay, we're going to be dealing with some quadratics here, so something with x squared. And then functions in standard form. Well, what's it mean if it's in standard form? To put something in standard form. What's it mean, sir? It's in order from exponents on down. So like our warm-up problem was x squared plus x minus 12. That is in standard form. Okay, so we're going to be talking about functions or quadratic functions. Quadratic because it's x squared. And then in standard form, they're going from descending order of degrees. Section 5.2 here. All right, vocabulary. There is a lot of key vocabulary here, so do pay attention. A quadratic function. A quadratic function is a function that can be written in the form f of x equals ax squared plus bx plus c. And again, I don't know why that has a box around it. But that's really the same thing as y equals ax squared plus bx plus c. Again, same thing as that. Okay? Now, I'm going to throw a question at you here, and I want you to think about it. It says where a, b, and c are real numbers, and a is not 0. Now, think about it. Why can a not be 0? Why can a not be 0 in that function or that equation? Why can a not be 0?
Get rid of the x squared.
Oh, this guy. Say it a little bit louder. That's correct.
It'd get rid of the x squared.
It would get rid of the x squared. Think about it. If you had 0 x squared, do you technically have an x squared? No, it eliminates that. That means it's a linear function then. It's no longer quadratic. Okay, great job. So yeah, you cannot have 0 as a, just because then it's no longer quadratic. Parabola. We're going to be talking a lot about parabolas this chapter. We're going to be focusing on this first part of it right here today. A parabola is the shape of a graph of a quadratic function. Who remembers what a parabola looks like? What letter? A U. A parabola looks like a U, or an upside down U, depending on how you want to look at it. Okay? We're going to be focused on those parts of parabolas. This other half of the definition right here, that will come if we get a chance to go to conic sections, which would be like at the very, very end of Algebra 2. So like April, May, June. Wait, I'm just kidding, not June. We're at school. But like way in the future there. Okay, we'll get to like what's called the focus and stuff. We're just going to be focused on the basics part of parabolas today. Axis of symmetry. Now this is something you're going to have to know for today. This is kind of the whole key to what we're doing here. The axis of symmetry is a line that divides a plane figure or a graph into two congruent reflective halves. Essentially what happens here is I have a parabola. Okay, I have this U. Now, a parabola is symmetrical. So I have an axis of symmetry that goes right down. Essentially, if you think of my hands here as a parabola, it is perfectly symmetrical to the other side. I could fold it up and everything matches up. Exactly. It is perfectly symmetrical. That is a big key to today. Okay, symmetry, same on either side. Okay. Standard form, we just talked about this last chapter again, but standard form is the descending order. So x squared, and then x, then constant. Your constant's always last. Your highest exponent's always first. The last two, if we have time, we will get to this. We have not had a chance to get to that in any class yet. But a minimum value is the y value of the lowest point on the graph. That would be, for instance, if I had a parabola that goes up, my vertex, or my vertex down there would be the lowest point, or my minimum value. All right, that's the vertex. That would be the minimum. And why is it the minimum? Because the graph goes up on either side. So it's going to go up and up and up and up and up and keep going, but it's only going to go down to where that vertex is, that point. Then we get a maximum value, which would be the other one. Nice question. Good segue into that. Nice job. If it's flipped around, as Nick said, then you get what's called a maximum value. Now, to think about that here is Mr. Whithelm over there is, a pretty decent basketball player in his own. When he shoots a basketball, now again, this is why parabolas are kind of unique. When he shoots a basketball, it actually makes a parabola. Anytime you shoot a basketball, it makes a parabola to go into the hoop. Okay. Some of you might remember when you had me in Algebra 1, we watched some videos on it, shooting the basketball. Do you guys remember that?
Yeah. No.
Except if you're like,
Skittles, man.
it goes like this.
You might have a chance to do that.
Wait. Oh, yeah.
Maybe.
Hated that Skittles.
No, I liked it.
Alright,
I
got
got call it like you're revealing.
No, I got the best grade in there, remember?
Remember?
No, Kelly and I were partners.
We talking. I was never
Spoon feed.
Yeah, but
Anyways, what happens here is we get a maximum value. Okay. Anytime you shoot a basketball, you do a lot of things with projectiles. You get a parabola. That highest point that your ball gets to, that would be like your maximum. Same thing. Colton is a golfer. Okay. Anytime you hit a golf ball, it's the same thing. It makes a parabola. A baseball, throwing a baseball, perfect. Softball, same thing. Softball, great parabolas. We did use the instance earlier. Like a hockey puck would be a small parabola. Football would be a perfect parabola.
I know.
If your receivers could catch the ball, it'd be even better, probably.
Looking at Jeff, your star basketball player. Yeah.
I say you just saw a star basketball player.
I'm talking about me, bro.
Anyway, so the next one here. This is kind of the process we're going to go through. I do have a steps page that we'll go through in a little bit. This is from the book here. Okay. Again, a parabola, or a quadratic, I should say, always takes this form. Ax squared plus bx plus c, where a is 0. That is something you have to be able to identify. It's ax squared plus bx plus c. Essentially, it goes in alphabetical order. The a is associated with the quadratic. The b is with the linear. The c is my constant. Now, this next one here. If a is greater than 0. Okay, so if a here is greater than 0. Well, then my parabola opens upward. Okay, that means I'm having a U-shaped parabola. If a is less than 0, essentially if I have a negative x squared, then my parabola is going to go down. Now that is good to note just so you have kind of a self-check for yourself. Just something to identify, is your graph correct? Does it look correct? The next part here, the axis of symmetry. This is the part that is key to what we're doing today. This is key. The axis of symmetry, that is the line that would go right down the middle of it. So for instance, right here, that's the axis of symmetry. Okay. That line right there that I'm kind of walking on the top of there. That's the axis of symmetry. That is the perfect point where you can fold your parabola. That is the key to be able to graph parabolas like we're going to do today. You have to know this. This formula right here is going to be used a lot as we go through today. And students make a lot of mistakes on there. You know what they always want to forget off, or leave off? That negative right there. It's negative b over 2a. Now, where do b and a come from? They come from our quadratic. A is what goes in front of x squared. B is what goes in front of x. Those are the two things we're going to need to find our axis of symmetry. Now, after that, we have to find the vertex. Now, they make it a little bit more confusing here, but our vertex is going to be a coordinate. Okay, it's going to be a coordinate here. There's our vertex. Really, they make it a lot more confusing. Really what happens is you find the axis of symmetry, you're going to plug that in to find your vertex. Okay, you're going to take the axis of symmetry and plug it in to find your y value. All right, and our vertex here is a coordinate. And then one of the last things we're going to do today is we're going to find the y-intercept. The y-intercept, as always, will always be your constant. So always your constant will always be your y-intercept, 2. And then because parabolas are symmetrical, if it's 2 over there, it'd be same side on the other way. So, here's what this looks like today. So, I want to identify some properties of this parabola. I have f of x equals x squared minus 4x plus 3. Now remember, quadratics, the standard form of quadratics is y equals ax squared plus bx plus c. So understanding that that's the common form there. Pat, it looks like you're doing a great job already. What is a? So as I look at this quadratic right here, what is the value of a, sir? It is 1, because there's an invisible 1. It's like saying 1x squared. What is the value of b, sir? Negative 4. And the value of c, sir? 3. Nice job. So right there, we just identified a, b, and c. We need that information to finish filling the rest of this out. Number 2 says the graph opens which way? Well, a is 1. That's a positive 1, which means my graph's going to open which way, Harv? Up. My graph will open up. Good work. Number 3. This is the one that is key. Number 3. This is the one we're going to have to do a lot of today. Ooh, I don't like that color. There we go. Axis of symmetry. X equals negative b over 2a. So I'm taking the b value I found in step 1 and the a value I found in step 1. So this is going to be negative 4. Now why do I have 2 negatives there? Well, because the b is negative and I have a negative right in front of b2 over 2a. So I have the negative of negative 4 all over 2 times 1. Now again, I get that both from, here's my 1, here's my negative 4. That's where I got both of those values. From there, I just simplify. 2 negatives get me a what, Jesse? Positive. 2 times 1 is 2. 4 over 2 gets me 2. So x equals 2 is my axis of symmetry. Which means now, as I look at my graph, my axis of symmetry will go right on down that line. Because recall, x equals would give me a vertical line. So our axis of symmetry is vertical right through that point. Now, step number 4. This is the one students look at this and they're like, oh my gosh, I don't even know what that is. There's like an f, parentheses, there's that negative b over 2a. What that means here is you take this value and plug it in to this equation, basically. All right, that's all that means. Is you find your axis of symmetry and you plug it in to find your vertex. So I'm going to have now y equals 2 squared minus 4 times 2 plus 3. And again, those 2's come from my axis of symmetry. From there, I just need to simplify. 2 squared is, I'm going to do that work down here. 2 squared is 4. 4 times 2 is 8 plus 3. So I have 4 minus 8 plus 3 gives me what, Lane? 4 minus 8 plus 3 is what, Lane? Negative 1.
Oh, so 4, you just take,
2 squared, which is 4.
you just like plug in the axis.
Yep. Yep. Take it in. Yes. 4 minus 8 is negative 4. Negative 4 plus 3 is negative 1. You with me now? Okay. Next one here. Now I need to find the vertex. The vertex is nothing more than this x value and this y value. My vertex is 2, negative 1. So I'm going to plot 2, negative 1. There's my vertex right there. And then the last thing here is to find the y-intercept. Who remembers what the y-intercept is? The y-intercept is just my constant. Nice job. Y-intercept is my constant. What is my constant, Jesse? What'd you say, Jesse? 3. So I plot my y-intercept. Positive 3. Now, here's the one that students start thinking, well, they get that, but how do you get the points on the other side? So you have to remember, this is my axis of symmetry. What's it mean to be symmetrical? Same on both sides, right?
Yep.
Okay, so here, I want you to notice something. That highlighted spot right here. What's the distance from the dot to the line? 2. So because it's symmetrical, what's the distance have to be on the other side? 2. So you get a dot right there as well. Because it's 2 here, it's got to be 2 there because it's got to match up on both sides. All right? And then the last thing we're going to do is I want you to sketch the curve. Oh, that's kind of a bad one. There we go. And realize now, this is a parabola, it is a curve.
How do you get the vertex?
I find the axis of symmetry, and then you plug the axis of symmetry in to get the y value.
Oh, the y.
Okay? That's all right. I have another, gentlemen,
Move them.
I have another slide after this that goes through the same steps in kind of a more fashion your way. Okay? So here's essentially really what we're going to do today. We're going to find and graph the axis of symmetry. Again, this right here is key. Knowing that this is the standard form helps. Negative b over 2a. You have to know that. The biggest mistake students make, and I had a couple I did earlier today, they forget the negative. Every time a student will forget the negative, and then it just messes everything up. Gotta remember that. Step 2, find and graph the intercept. Find and graph the vertex. Using the x coordinate from step 1, plug in to find y. I get a vertex then. Step 3, find and graph the y-intercept. That's just my constant c. And then I do its reflection. Okay, so I find c, and I do its reflection. Step 4, evaluate the function for one other value of x. It does not matter. You choose the value. All right, now there are some values that are easier than others, but you choose the other x value. Now, when you're thinking about this, which values are always easiest to plug in? 1, 2, 3, 4. Could I have 0? Why not? Nice job. Why could I not plug in 0? Because it's already at my y-intercept. My y-intercept is where x equals 0. So I already have that located, actually. All right, then the last thing we're going to do is sketch the curve. All right, so number 5 is sketch the curve. Again, we're going to go step by step through this. Follow along. If you have questions as we're going through, ask. Okay. So number 7 here. I want you to graph y equals x squared minus 2x minus 3. I'm just going to kind of do my steps over here so I can get it all on the board here. But step number 1, find my axis of symmetry. Shh. Let's see here. Find axis of symmetry. How do I find the axis of symmetry? What special formula do I need? Is the big one, Colin? X equals negative b over 2a. Nice job, sir. So I need to find my axis of symmetry. What is b in this quadratic? So I'm looking at this quadratic right here. What is b? Negative 2. So I have negative 2 over what is a? Jack? 1. Nice job. So 2 times 1. And from there, I simplify. 2 negatives get us a. So I get positive 2 over 2, which is really just 1. My axis of symmetry is x equals 1. So I'm going to put a vertical line right through x equals 1. Awesome. That's step number 1. That is the step that if you can't do that step right there, you can't go on and do the rest of it. Just in all reality, you can't. You have to get that first step down. Step 2 now. Step 2. Plug in number 1's answer. Okay, so I'm going to take number 1's answer, and I'm going to plug it in, because I need to find my y value. I need to find my vertex. So that means I get y equals 1 squared minus 2 times 1 minus 3. Again, where did I get that 1 at? I took it from step number 1. I found my axis of symmetry is 1. Took that 1, plugged it in for both of my x values. And now I just simplify. So 1 squared is 1. 2 times 1 is minus 3. 1 minus 2 minus 3 gets me Harv.
-4.
Nice job, sir. Y equals -4. Now I have my vertex. My vertex is located at 1, -4. Because it's that value along with that value. I get my axis symmetry. So I'm going to plot 1, -4. Right there. How are we doing, Tiana? Got this? Good. Step 3. Find the y-intercept. Jesse, what's my y-intercept always?
Oh, constant.
Y-intercept is always my constant. So I'm looking for a C. C is -3. So I go to my graph and I plot my y-intercept, -3. Now, here's the thing you always need to remember. Parabolas are what? Symmetrical. They're symmetrical. They're mirrors. That's another way to think of it. Nice job, sir. They're mirrors. So if this one is plotted here, my other side needs to be plotted there, because it has to be symmetrical. So I plot the reflection, which is the point right there. Does everybody understand how I get that second point? Mirror image, reflection. Now, step 4. This is the one. Now students start questioning themselves. Okay? Step 4. Pick one more value to evaluate it. And here's why I ask you to pick one more. Because a lot of times I'll get students that graph this and they're like, oh yeah, I'm done. Whew, my parabola looks like that. Is that a U? No, you can't really see the curve there. Okay, the idea of this is to see the curve. And that doesn't show the curve really. Alright, so we're going to pick one more value. So step 4, pick an x value. I get to choose the x value. I can technically choose any value. Now, this is the one where I say, I want you to think logically, pick the next value. I already have where x is 0. X equals 0, y is -3. I have 0, -3. I have x equals 1, because I have 1, -4. Does everybody see that? I have 2, because it's 2, -3. What's another value that I can choose? 3. 3 would probably be the next best value. If I didn't want to choose 3, what else could I pick? 4. If I wanted to pick something else, what could I pick? What'd you say? I could choose -1. I could choose any other value of x. If I wanted to, I could choose 1/2. If I really wanted to get crazy. Why choose a fraction? That's just more work, right? So again, you pick the values. We're going to pick x equals 3. Okay? So we say x equals 3. Well, now I pick the value of 3. I have to plug it in. So I plug x equals 3 into my equation. So basically I'm going to do step number 2 again. I take x equals 3 and I plug it in to find y. So I get y equals 3 squared. No. Minus 2 times 3. Minus 3. Okay? And again, what happens here is this 3 goes into x. I took this 3 and put it into x values up there. And now I just evaluate. 3 squared is 9. 2 times 3 is minus 3. 9 minus 6 minus 3 is
0.
Y equals 0. So y equals 0. So now I plot the coordinate 3, 0. And after I have that coordinate, what do I need to do? I need to do its other side, reflection. Awesome right there. Now can we start seeing the curve? Well, yeah, now I can see how it curves up here. Going something like this. And now I have my parabola. Alright? Again, yes, it is kind of a lengthier process. Once you get the hang of it, It's really not that bad. It's like anything. You just kind of need to get some practice with it. All right? All right, number 8. Now let's try number 8 here. Shh. Number 8. Couple things to recognize here. What do you notice right away about the problem?
There's no B.
There's no B.
0.
So B is 0. Nice job. So step number 1 is I need to find the axis. Okay? I need to find the axis of symmetry. Well, to find the axis of symmetry, what formula do I need to use? It's that popular one. I said you need to use it on every single one. What is it, Tiana? Nice job. So negative B over 2A. Now, Autumn, you said B was 0. So really that's negative 0 over 2 times 2. Jesse? Shh. Jersey, thanks. Well, negative 0 over 4 is going to be 0. My axis of symmetry is actually right there, right in the middle. Interesting. Cool. Kind of unique.
Like me.
I know. So the next one here. Step 2 says plug in. So I plug in my answer from number 1. So what value am I going to plug in? I'm going to plug in 0. Giving me y equals 2 parentheses 0 squared minus 4. Well, 0 squared is just 0 times 2 is minus 4 is negative 4. 2x squared. So I have y equals 4. Oh, sorry. Y equals negative 4. What is my vertex now? My vertex is 0, negative 4. I have my 0. I have my negative 4. Now I have my vertex there. 0, negative 4. Now, step 3. What's step 3 say?
Find and graph the y-intercept.
Huh, what do we notice about the y-intercept here? It's already done, right? Because my axis of symmetry is on the y-axis. My y-intercept's already done. Huh, cool, okay. So step number 4 now.
Find another value.
I need to pick an x. I get to pick another x value. I want to do 2 values. What would be the best value to choose?
1.
Let's pick x equals 1. Sounds like a great idea. I'm going to pick 2 values.
I thought you were going to say 2.
Oops. So let's do x equals 1. If I plug x equals 1 in, oops.
Last time I remember giving you
I plug in x equals 1, so I get y equals 2 parentheses 1 squared minus 4. 1 squared is 1. 1 times 2 is 2. 2 minus 4 is
2.
negative 2.
Negative 2.
So I get the point 1, negative 2. And once I plot that one, I always need to do the reflection, or the opposite over there. Awesome. Now, because our line was on the axis of symmetry, I'm going to ask you, I know, I'm sorry, I want you to pick one more value. Just because I always want 3 on the side. So what's the next best value to pick, Jack? 2. Well, let's pick x equals 2. That seems logical. We're kind of going in that order. Let's do x equals 2. So now I get y equals 2 parentheses 2 squared minus 4. 2 squared is 4. 4 times 2 is minus 4 is 4. So I get the coordinate now 2, 4. There you go. And stop, please, sir. There is my graph right there. Kind of a steeper parabola.
What? 2.
Next one here.
Oh my gosh. Everything that what you said.
Take a couple seconds. Try this one on your own. Go through the process. Find the axis of symmetry. Find the vertex. Work this out.